Good morning, Ananda. Welcome back to the video lecture series. Signal systems. Today we are going to discuss about problems on periodics. Now already we have seen the condition for periodicity in time domain as well as in continuous time in discrete time. Suppose in the continuous time as well as in discrete time, suppose there is more than one signal in this, that is multiplication of two signals or addition of two signals or addition of three signals like that. In this case, how to find out periodicity? Suppose the signal is a periodic signal. How to find out periodicity? Suppose the signal is not periodic signal, so no issue. We no need to calculate periodicity for this. So here you observe this one, the condition for periodicity. In this case, there is a combination addition of two signals, x1 of t plus x2 of t. So here you need to calculate, first of all, find out the period, check whether x1 of t is periodic or not. Suppose the signal is a periodic, then find out the fundamental period. And second, you see the x2 of t, this x2 of t is a periodic or not. Then you find the periodicity for this one, and then you suppose both the signals are periodic, and then you calculate the ratio of these two, ratio of T1 by T2. Then this ratio is a rational number. This ratio is rational number. Then we can say that the signal is periodic. Suppose rational means the ratio, whatever the numerator and denominator, both are integers. Suppose these two are, the ratio is irrational, then we can say that it is a non-periodic signal. Similarly, coming for discrete time signal, if you observe here, there is a x1 of n plus x2 of n, addition of two discrete time signals. Now, individually, you check whether x1 of n is periodic or not, x2 of n is it periodic or not. Suppose x1 of n is a periodic, x2 of n is a periodic, and then the ratio of first period n1 divided by n2 is equal to, this is a numerator and denominator both are integers, then you can call it as a rational number, then we can say that it is a periodic, otherwise it is a non-periodic. Next one is even and odd signals. Second classification is even and odd signals. Now, we are going to see the problems on this periodicity, and then we go for this even and odd energy and power. We will see before going to the next classification, we are going to check whether the given signal is periodic or not. Now you observe this one in this. Determine whether the following discrete time signals are periodic or not. If periodic, determine the fundamental period. If periodic, determine the fundamental period. You observe first one, x of n is equal to cos of, it is 0.01 pi is nothing but omega naught, cos of omega naught. Okay. And second case, second problem, cos of omega naught. Omega naught place in omega naught with 3 pi. Next, if you see addition of two signals here, there is a addition of two. It is x1 of n, it is x2 of n. So it is omega 1, it is omega 2. So here you find out n1, here you find out n2, and you find out the ratio of n1 and 2, and then you see the ratio is a rational or irrational, then suppose it is a rational number, then we can say that it is a periodic. And you see here a product of those two signals, whether it is a multiplication case or it is an addition case. Now you need to see fundamental, you need to convert this is into this product term is become, you are going to be converted to addition of the two signals. Then we are going to check fundamental periods of individual signals. Next, you see the sixth one, again, sine omega naught n plus theta. So there is no any effect on periodicity because of phase shift, whether it is a delayed or it is advanced phase shift. So you don't bother about this periodicity, you don't bother about this phase. You are going to concentrate on fundamental frequency. Here also you see e power j omega naught n. Here omega naught n, we are going to be concentrate. First you find out omega naught in every sequence, and then what is the f naught. If f naught is a rational number, that is a ratio of two integers, numerator and denominator both are integers, then we can say that that particular sequence is a periodic sequence. Now you observe this one, x of n is equal to cos omega naught. So here you take this omega naught. Omega naught is equal to 2 pi f naught. Omega naught is equal to 2 pi f naught. Here he has given only f, but usually fundamental frequency. So we are going with f naught. F naught. Don't confuse here. It's given only f. You assume whether it is omega or omega naught n. So here anyway we are with omega. So 2 pi f n. So n cancel, pi cancel. You see f. F is equal to 0.01 divided by 2. So you multiply numerator and denominator with 100. You will get 1 divided by 100. You will divide by 200. It is equal to k by n. It is a ratio of both are integers. So it is a rational number. So it is rational number. So whenever it is a rational number, we can say it is a periodic signal. Now, what is the fundamental period? You need to you need to compare this one with the k by n. Here k is an integer, n is a fundamental period. Okay. Next, you see the second. Now, this sequence is a periodic with fundamental period n is equal to 200. Next, x of n is equal to cos 3 pi n. Now, observe here omega in the omega is a 3 pi. So 2 pi f, omega is equal to 2 pi f, it is equal to 3 pi. Then f is equal to 3 by 2, it is equal to k by n. So here k is equal to 3, n is equal to, so it is a rational number with fundamental period n is equal to 2, means after every 2 samples, this cos signal is repeated. Okay, next. Now you see sine 3n. The sine 3 here, instead of omega, only we have a 3. So 2 pi fn is equal to 3n, f is equal to k by n. So it is, if you observe it is not a rational number, because you must, for periodicity condition, both signals must be integer. Here, numerator is an integer, denominator is not an integer. So it is a irrational number. So it is a irrational number. The signal is a non-periodic signal. Non-periodic signal. Next, you see x of n is equal to cos 2 pi n by 5 plus cos 2 pi n by 7. It is x1 of n. It is x2 of n. X of n, combination of two signals or two sequences, x1 of n plus x2 of n. This x1 of n, whatever the x1 of n, in this you observe omega 1 is 2 pi n by 5, omega n. So omega n means 2 pi f1 n. So from this you calculate first of all f1. From that f1 you will get k1 by n1. F2 K2 by N2. So fundamental period N1 is equal to 5, N2 is equal to 7. Now in this case, you take LCM of these two signals and then you will get the least common multiples, nothing but common period per periodic signal. Okay, because of time being, the video I am going to stop. It is not uploading. So we'll see in the next class. Thank you.